biodegradable polybags. This is also we have applied for patent, and this we have prepared it from formaldehyde modified thermoplastic starch and its subsequent blending with LDP. And usually in industry these LDP bags are used, which are creating havoc to the atmosphere, to the environment, as it is polluting the environment, it is creating later, etc. So that's why So that's why we have developed this product, which is very important to the society. This is the introduction of our product. India, being agrarian in nature, produces a lot of starch such as potato, rice, wheat, and maize or corn starch, and other starches also. LDP of high molecular weight being non-polar is biodegradable, and Government of India has banned LDP bags with thickness of below 70 micron. As starch is biodegradable natural polymer, it can initiate biodegradation of LDP if they form at least a compatible blend on their mixing. Natural starch being crystalline cannot be blended as its melting point is more than 250 degrees Celsius, so it can be used as a filler. Whereas this thermoplastic starch, what we have developed in our lab, it can be blended, and it is a plasticized from natural starch obtained from natural sources such as cassava, maize, potato, along with the plasticizer. So thermoplastic starch is mainly amorphous, whereas ordinary starch is crystalline. The commonly used plasticizers are polyfunctional alcohols such as glycerol, sorbitol, along with some low molecular weight compounds capable of forming intermolecular hydrogen bonding such as water and formamide, etc. The starch and plasticizer, in the presence of heat and constant excitation, undergo gelatinization. So in that process, crystallinity of starch is sufficiently reduced, leading to the amorphous structure, what it is known as amorphous thermoplastic starch. Due to its amorphous character, it can be blended with LDP. So what is the summary? This is the summary of the invention. What we have patented. The present invention is to make a thermoplastic starch composition, a method of making thermoplastic starch, and a biodegradable polyethylene film. The thermoplastic starch is a blend of starch with a plasticizer to improve gelatinization, and another plasticizer or reactive compound such as formaldehyde to reduce retrogradation in thermoplastic starch. A biodegradable polyethylene film is obtained by blending with thermoplastic starch pellets with polyethylene in the presence of an effective compatibilizer. This is the novelty of the invention. In the present invention, for production of thermoplastic starch with minimal retrogradation, formaldehyde 37% formalin solution is used as an effective plasticizer as well as modifier in addition to glycerol. Very small proportion, not more than 5%. The water present in formalin solution is used as plasticizer, helping in better gelatinization. This is the claim. In accordance with one embodiment of present invention, the thermoplastic starch is disclosed that comprises about 50 to 78% of at least one starch. Here it is maize starch, and about 38% to 48% of at least one polyol. Here it is glycerol, and about 1% to 5% of at least one low molecular weight aldehyde. Here it is formaldehyde. So, in accordance with another embodiment of the present invention, a biodegradable film is disclosed, comprising about 50 to 78% of one thermoplastic starch, what we have produced in the first claim, and 20 to 38% of polyethylene, here LDP, of about 10 to 28% of another copolymer of polyolefin alcohol copolymer, here it is EVOH. So materials used already have discussed, already have mentioned maize starch, glycerol, formaldehyde, low density polyethylene. We have used Reliance grade 24FS040 with low density 0.922 gram per cc, and melt flow index MFI is 4 gram per 10 minute at 190 degrees Celsius. We have used EVOH also. It is Eval EVOH obtained from Korea, America. So these are the processing methods. We have used high-speed mixer which can go up to 20,000 RPM is used initially to mix plasticizer along with the starch. That is also helping in degrading, in breaking the bonds of crystalline starch. A counter-rotating parallel twin screw extruder with LD ratio of 26:1 is used for compounding and blending. I will show the extruder. The extruders were cut using pelletizer and made into pellets. Blown film extrusion machine is used to make blown films. These are the traditional machines what is used currently for making polyethylene bags, the polyethylene bags. So these are the traditional equipment, same equipment we have used. We have just some adjustment we have done such that we can make thermoplastic starch pellets, as well as during the blown film extrusion also we have made certain adjustment in temperature, etc. So otherwise it is the same machine. So this is the twin screw extruder we have used for making pellets of starch, as well as making blend of starch and thermoplastic starch and LDP. So this machine is used, and this is the process of making blown film extrusion. Here it is actually another extruder is used, and at the end this is the earring. We have a blown film die. Air is coming inside and it is blown. Those tubes are formed, and ultimately we have those pipes, etc., which can cut later. This way we can get those bags. These are the bags we prepared after getting. So this is the way it is coming out. Then we cut it and we can get those bags like this small bag. So big bag also can be done using the different extruder, blown film extruder. So we can, that is the possibility. We have experimental for the initial experiment, we have done that. So this is thermoplastic starch that I have already explained. This is the one can see it is there is a blown film extrusion. You can see that the air is coming and then it is blowing, and ultimately that shape is balloon shape is coming, and later it will be here it is. One can see that another inside here it is the ultimately it is coming out that way. Here we are collecting that way, and this is the ultimate collection here. So this is that way we can get the product, this product at the end, cutting it, and we are getting the product. Okay. So these are the products already I have shown. So this is the biodegradation test under anaerobic condition. Actually, this is very important test. As from this test we can understand whether the polybags we prepared, these polybags are biodegradable or not. From this figure one can see that it is more than 90% those polybags are biodegradable after 120 days, and this is whereas for cellulose powder we have used a positive, that is positive one, that is after 70 days it is 100% biodegradable, whereas polyethylene, only polyethylene, it is not at all biodegradable, it is only maybe 2 to 5% after 120 days. So this slides indicates that our product, what we got it, is biodegradable in nature.